take the surveys from the customers, which looks something similar to this or something similar to that. And using these check sheets, I'm going to transform them into normal distribution, which looks something like this. All the check sheets, I'm going to transfer them into this. So using the normal distribution, I'm going to shift them into control charts, which looks something like this. So these control charts will help me find the root cause. So for example, on all the days, it's okay, the training was good, they're doing the best customer service. But on Thursday, he didn't give the proper customer service to the person, to the customer, and hence he has given a poor customer rating. So I'm going to tell him, I'm going to train him properly what to do, what exactly to do, and from the next week, he's not going to do the same mistake. And the customer ratings will go up, again to 8.5. So that is how we identify problems using statistical process control. So 3 major steps. So we're going to talk in detail about 3 of these steps. The first thing is identifying issues. So how do you identify issues? Okay, we take the surveys, or this can be applied to any industry, like manufacturing industry, or basically any industry, automotive industry. So the first thing is we got 2 things. One is authoritative and expert talk. So what does authoritative analysis mean? Okay, we got the check sheets, that is the spreadsheets. We take all the spreadsheets, we do the quantitative and qualitative analysis. So this is like a solid evidence. We know, okay, this is something is going wrong. And using this evidence, we go talk to experts who has been working on this process since a long time. So when you combine this both, you'll be able to identify what's the issue. So this is how you identify an issue using statistical process control. So now the next step is normal distribution, which my team member Chris is going to talk about. Chris?
So by definition, the normal distribution is a function that represents the distribution of many random variables of data as a symmetrical bell-shaped graph. It's always symmetrical about its mean. It approaches the horizontal axis on both the left and right side of the graph without touching it, with response to an asymptotic boundary condition in the x-axis. As I mentioned before, it's a bell-shaped curve, which has its transition points at ±1 standard deviation from its mean. So, from a normally distributed set of data, 68% of the data exists at ±1 standard deviation from the mean, 95% of them at 2, ±2 standard deviation from the mean, and 99.7%